Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, hey, we haven't even been replaced by AI yet. This is incredible news. Everyone, I hope that you're doing well and you are ready for today's program, because today we have the one, the only Mr. Ralph Bond joining us here in just a moment to talk all about a number of very fun stories. You know, some of them space, some of them science, some of them medical, all of them very, very fun. It's not like you're going to hopefully be reading these and being like, oh no, this is terrible news. No, Ralph doesn't usually come around with terrible news. It's only the good stuff from him. So everyone, computeramerica.com, that's where you'll find everything, social media links, articles, links to the show notes. Show notes are very important because they include just about everything that Ralph talks about, and including sources. So if you ever want to find out more, go ahead, computeramerica.com, and of course you can find everything that Ralph does right there. Also, on top of that, just want to say that, you know, going over the news this morning, just, you know, feeling out how's the day going to be, and you see an article like Germany has too many solar panels, it's pushed energy prices into negative territory. You know, stuff like that is encouraging. It means, hey, we're doing the right things and doing them more and more. So, ladies and gentlemen, it's going to be a Good Friday, and not the Good Friday, but it's going to be a Good Friday, and it's going to be a lot of fun. So let's go ahead, bring Ralph on, and get things started. So, as I said before, Ralph Bond, he is our science and technology trends correspondent, and if you want to know what that means, well, stick around. Ralph, welcome back onto the program. How you been?
Great. It's great to be back. And I'll tell you, to amplify on what you just said in your introduction here, if you're a first-time viewer or listener to our show on Fridays, what we do is look at where we're headed, trends in robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it, all across the board. And basically, what Ben and I do is provide you an oasis of positive news, thanks to the world of science and technology. So we're going to start off with two space-related stories. Really fun stuff.
Yep, this is going to be a lot of fun. And again, show notes if you want to find more of these. And if you're watching the video portion, we're going to show demonstration videos and stuff like that. But by and large, if you're just listening, sit back, relax. And Ralph, let's go ahead and just kick off story number one.
Yeah, story number one comes from space.com, a great outlet, by the way. And this is a bit geeky, so I don't profess to fully understand all this stuff, but here's the headline. NASA funded pulsed plasma rocket concept aims to send astronauts to Mars in just 2 months. And we'll put that into perspective in a moment here, where the article does a great job of explaining that. So here we go. The goal of landing humans on Mars has presented a myriad of challenges, including the need to quickly transport large payloads to and from the distant planet, which, depending on the positions of the Earth and Mars, would take almost 2 years for a round trip using current propulsion technology. 2 years. So remember, the headline said this engine might do it in 2 months. Mm-hmm. What?
It really cuts down the time. That's great.
Well, yeah, and that's why this just grabbed my attention, even if I don't fully understand the technology. Thought I had to share this with everybody. So now there's an innovative rocket system that could revolutionize future deep space missions to Mars, reducing travel time to the red planet to just a few months, as we mentioned in the headline. And here's the technology. The pulsed plasma rocket under development by Howe Industries. And by the way, the show notes have links, as Ben mentioned, links embedded into the articles. I also add optional side notes for further education. So really, please come out to computeramerica.com. Get the show notes if you want to dig deeper. So again, the pulsed plasma rocket under development by Howe Industries is a propulsion system designed to be far more efficient than current methods of deep space propulsion, enabling the trip between Earth and the red planet to be made in just 2 months, as we said a couple times before. Now, specifically, the rocket will have what's called a high specific impulse, which is a measure of how efficiently an engine generates thrust. This technology could therefore enable astronauts and cargo to travel to and from Mars more efficiently and rapidly than existing spacecraft, according to a statement from NASA. And in the show notes, we have that link to the official NASA statement about this technology. It's just really cool stuff, Ben. It's just utterly transform and make more possible, I think, traveling to and occupying ultimately Mars itself. So pretty cool stuff.
Yeah, I had no idea that because on the show we've covered solar sails, we've covered kind of fusion reactors on spaceships.
Right.
There's a lot of different ideas for propulsion. This is a new one for me. I've never heard of that one completely. Although it would totally change the movie Rocket Man, if anyone remembers that 1997 movie. It's a really cool idea. And it really makes you think of, like, they mentioned cargo, because I guess as a layperson, I'm always like, when are we getting astronauts there? When are we going to get boots on the ground? When are we going to get people to Mars? But I guess there's a lot of infrastructure that probably has to go ahead of them. And even not ahead of them, just has to continuously flow to Mars. And that's interesting. And stuff like this is going to be very crucial. So,
not only cargo, Ben, but human beings, of course. It's one thing to say, oh, guess what, Joe or Sally, you're going to be on this spacecraft for 2 years, or at least 1 year there and 1 year back, whatever the case may be. That's an incredibly difficult thing to put food and sustenance and so forth on a spacecraft for that long a period of time. But if you say 2 months, that's doable, both physically and psychologically, I think. So it's a really big breakthrough.
I mean, like, the engagement for this really was highlighted by that open casting call a couple of years ago, if you remember. I think it was SpaceX and Elon Musk, and he's like, hey, who wants a one-way trip to Mars? And, like, thousands, and like at the time it was one way, and he's like, thousands of applications came in, Ralph. They were like, oh, I'll go to Mars, I'm done with Earth, I'm ready for Mars. And even with it being one way, Ralph, it was a surprising amount of people wanted to take part in this. They got a lot of applications. Obviously now it's like mandatory, two-way travel, but still a lot of interest in Mars. So I hope that this technology really catches on. So
So we'll pick up a little more about this technology. So it's derived from the pulsed fission fusion concept. How Industries rocket uses a fission-based nuclear power system, which obtains energy from the controlled splitting of atoms to generate thrust for spacecraft propulsion. This makes the Howe Industries pulsed fission fusion rocket smaller, simpler, and more affordable than previous concepts. So not only is this thing going to get you to Mars in a month or so, it's also less expensive and simpler. You got to love that combination. Now, in the show notes,
I think like less expensive is in quotes, by the way. This is not, save up your lunch money, but yeah, please continue.
That's true. And in the show notes, for all of us geeks out there who want to know more, and I did a Copilot AI search. By the way, Copilot was offline yesterday for quite a long time.
How dare it?
But anyway, it's back. It's back. Anyway, so in the show notes, I have an optional geek out section, a side note. You can learn more about what a pulsed fission fusion rocket is. You can learn about what is meant by specific impulse. You can learn about the high thrust capabilities of this particular design. So, but with that said, you can go and geek out on that if you go to the show notes. Let's pick up. In addition to enabling longer range missions, the Howe Industries pulsed plasma rocket could support much heavier spacecraft, meaning additional shielding could be installed to reduce a crew's exposure to harmful high-energy particles called galactic cosmic rays endured during long-duration spaceflight. And you know what, Ben? I said, okay, I have to share this side note. Galactic cosmic rays sounds like something from Marvel comic books. What these are, they're high energy particles or clusters of particles that traverse space at nearly the speed of light. And these cosmic rays primarily consist of protons or atomic nuclei. So fascinating stuff there. And to go on here, the pulse plasma rocket concept is now moving into phase 2. So this has already been in phase 1 trials and testing and so forth. So it's moving into phase 2 of the NASA Innovative Advanced Concept Study, having completed phase 1, which focused on. So phase 1, which has already been completed, now we're moving into phase 2. But phase 1 looked at the neutronics of the propulsion system, and neutronics, also known as neutron transport, is the study of the motions and interactions of neutrons with materials. So it looked at neutronics. It looked at the designing of the spacecraft that would use this propulsion system, power system, and necessary subsystems, analyzing the magnetic nozzle capabilities. There's a whole story behind that, too, if you want to dig deeper, and determining trajectories and benefits according to the official statement. And to wrap it up here, during phase 2, developers will build upon the assessments from phase 1 to optimize the engine design, perform proof of concept experiments, and design a spacecraft concept to better protect crewed flights or manned flights to Mars. So cool stuff.
Yeah. So phase 1, which just wrapped up, is it possible? Phase 2 is, can we build it? And then I guess phase 3 and 4 is like, let's build it, and then let's do it. But still, phase 1, getting out of that simply, and I'm sure a lot of ideas don't even do that. Very, very cool idea. So, Ralph, and I'm always amazed that, like, obviously NASA has a formula for, getting satellites into space and doing these missions, getting rovers, but they're always looking for the next best improvement. And that's, I guess what NASA does best. I guess that's why, Ralph, it's like whenever you mention someone doing something smart or having to do something very difficult, it's like, well, it's not rocket science or, it's not rocket surgery, whatever it is. But yeah, there you go. So good luck to NASA figuring out how to get pulsed plasma rockets going. So there you go. Story number 1. We're going to focus on something a little bit more simple and an emphasis on a little. Because, like you said, this is also a space story, and it's about SuperLimbs. So before you get too excited and thinking like, oh, this is going to be something that you can use here on Earth, maybe. But honestly, Ralph, like I read this and I was like, this is Spider-Man. Doc Ock. Those giant flailing arms. Speaking of Marvel. So story number 2.
Yeah, you're right. That's a good comparison. This comes from MIT News. And the headline here is Robotic SuperLimbs could help moonwalkers recover from falls. A new MIT system could help astronauts conserve energy and extend missions on the lunar surface. And this is a very visual story. So friends, please come out and get the show notes if you're listening to us as a podcast. And then also go and look at the YouTube video that'll be produced from this interview or from this show as well. So anyway, MIT News, great image here in the show notes, kind of a graphic design concept showing an astronaut who's falling on the surface of the moon, and these curious like extension arm things helping him or her avoid collision to the surface of the moon and also to bring themselves back upright. So it's really a cool story. So, and it starts off, I love the way this article starts off. Need a moment of levity? Try watching videos of astronauts falling on the moon. Remember the old videos. NASA outtakes of Apollo astronauts tripping and stumbling as they bounce in slow motion are delightfully relatable. For MIT engineers, however, the lunar bloopers also highlight an opportunity to innovate. And then it talks about this fella here, Heriot-Watt, professor of mechanical engineering at MIT, notes, quote, astronauts are physically very capable. We all know they're extremely physically fit, but they can struggle on the moon where gravity is 1/6 of the Earth's, but their inertia is the same. That's an interesting thing to think about. He goes on to say, furthermore, wearing a spacesuit is a significant burden and can constrict their movements. We want to provide a safe way for astronauts to get back on their feet if they fall. So there's the motivation.
The video that we're kind of showing in the background, and it's included in the article, they make a good point here where it's like body restrictions from spacesuit, unfamiliarity, gravity inertia balance, like you said, but also limited visibility, which I didn't think about. Like, you can't exactly, bend over and look down at your feet and see where you're placing your feet in totally unknown terrain. So many limitations.
That's a great point when you're in the big, heavy suit and you've got the helmet and so forth. You're right. It's difficult to kind of, your natural inclination when we walk on Earth, of course, is to keep an eye on where we're going, hopefully.
Can't do that.
Yeah. So Asada and his colleagues are designing a pair of wearable robotic limbs, and I would say like extra arms, that can physically support an astronaut and lift them back on their feet after a fall. The system, which the researchers have dubbed supernumerary robotic limbs, or let's simplify it, SuperLimbs, which they do too, is designed to extend from a backpack, which would also carry the astronaut's life support system along with the controller and motors to power the limbs. It's really very cool. The researchers have built a physical prototype as well as a control system to direct the limbs based on feedback from the astronaut using it, so it interrelates with the astronaut. The team tested a preliminary version on healthy subjects who also volunteered to wear a constrictive garment similar to an astronaut's spacesuit. So they tried to simulate this experience. And when volunteers attempted to get up from a sitting or lying down position, they did so with less effort when assisted by the SuperLimbs. I think I'd like these too, compared to when they had to recover on their own. In fact, there might be some real world on Earth applications for this for people with disabilities, by the way. Going on to conclude here, the design could prove especially useful in the coming years with the launch of the NASA's Artemis mission, which plans to send astronauts back to the moon for the first time in more than 50 years. So this is a fun story, and it's a little more approachable. And like you say, that character from Spider-Man who has the nemesis, who has all those arms. There you go.
Not quite, but actually, the renderings are very familiar. I'm sure inspired by it. It's and honestly, you never really consider like how difficult it is to even just walk on the moon. So these things are very effective. Although I kind of wonder, Ralph, like maybe something like something built into the suit itself, which I'm sure again much smarter people than I, and these people are working in conjunction with NASA, are going to be doing this, but. You would kind of think like something built into the suit itself would be more practical than something that kind of comes out of the suit or out of a backpack. Just another, kind of point of failure. But I don't know the best solution. And maybe, hey, some stabilizing arms that can kind of catch you in worst case scenario and, probably have other capabilities as well would be, much better. But still, it's cool that they're working on this, and like you said, the Artemis mission right around the corner. So we'll see. Story number 2, story number 3, and we have talked about. I think last time we talked about this, it was it mealworms? It was like little worms that were like eating.
Eating
totally
the
different
plastic,
story.
right?
Yeah, they were eating the plastic, and it was really cool because hey, it's. Plastic is seen as this kind of like insurmountable problem. Like we are addicted to the stuff. We can't stop using it. But at the same time, it is super invasive, getting everywhere. And, it's like, well, you can't stop using it, but you can't live with it. So what's the solution here? Story number 3, hey, might have an answer. And that's cool that we might have an answer. So, Ralph.
Yeah, this is a really cool story in the category of how do we deal with plastics? And Ben, you and I, over the many past years, have had so many different stories, so many great ideas for how do we break down the plastic? How can we recycle the plastic? On and on and on. But this story, the headline alone just grabbed me right away. It comes from ZME Science, a really interesting outlet. But here's the headline. Scientists make living plastic with bacterial spores that could put an end to forever plastic pollution. Subhead, the bacterial spores are incorporated into the bulk plastic. Interestingly, this plastic is more durable and flexible, mirroring the way rebar reinforces concrete. Okay, how can you resist that headline and subhead? I said, I got to know more.
I will say that, and it really does make a difference because, Ralph, there was if anyone out there remembers the sun chips from a couple of years ago, they're like, we have new plastic bags that use less plastic, that you can use their sun chip, and it's like everyone joked about how loud the sun chips bags were. They were incredibly loud when you're kind of trying to open them or use the bags. Like, Ralph, it's not just enough to have a solution that kind of makes the plastic worse and solves the problem. Like, people, I don't think will go for that. You need something that plastic can still do its job, but also it's still better for the environment. So this is a win-win.
Great. This is really quite interesting in the whole trend world of what do we do with plastics. I thought this story was particularly interesting. So here's a kind of a no-does statement in the article. Less than 10% of plastic in the United States is recycled. That's horrifying. With this percentage even lower in other nations, we all know this, I think. But in reaction to these challenges, biodegradable plastics have been advertised as the solution to plastic pollution problem bedeviling the world. These biodegradable and compostable plastics can be broken down into water, carbon dioxide, and biomass by microorganisms. We talked about the worms a moment ago. But here's the key that this article points out that I think is so important and why this story, this breakthrough, is so important. All of that's great, breaking it down to water, carbon dioxide, biomass by microorganisms, but only under the right conditions. There's the qualifier. And that's been the kind of problem, I guess you could say, or barrier to deployment with microorganisms used to break down plastic. So this is why this story is so cool. So here we go. Researchers at the University of California, San Diego, have now put a new spin on biodegradable plastics. And this change may finally usher in a new class of, I love this, guilt-free plastics. As the author says, one can only hope. And they've pioneered, a new type of thermoplastic polyurethane that is not only durable, but truly biodegradable. Thermoplastic polyurethane, by the way, is common in products ranging from footwear to memory foam, making it a staple in various industries. Now, here's the innovative twist. The innovative twist introduced by the UC San Diego team involves embedding bacterial spores within the plastic, which activate and break down the material, meaning the plastic, when exposed to nutrients found in compost environments or landfills. Think of landfills, which are kind of sort of like compost environments. And these harmless spores are essentially dormant bacteria ready to wake up when the time is right, such as when you've decided your plastic product has reached the end of its lifetime. And I think what they're saying here is when you discard the plastic and it winds up in a landfill or in a controlled composting environment, and then these little guys wake up.
Yeah, probably when it's exposed to sunlight, water, soil, nutrients. So when it just starts breaking down naturally, which, like you said, can take, plastic before can take hundreds or thousands of years to break down. This is more like days. So cool.
Yeah, pretty cool stuff. And this research now in specific, what's the star of the show here? What's this bacteria? Well, it's called Bacillus subtilis. I hope I'm saying that right. A bacterium known for its ability, to decompose polymer materials. Little side note, just real quick. Bacillus subtilis, also sometimes referred to as the hay bacillus or grass bacillus, is a gram-positive rod-shaped bacterium commonly found in soil and in the gastrointestinal tract of animals and humans. I consider myself an animal, so that's one and the same thing. But isn't that interesting? These little guys are inside of us right now.
And to your little side note, I guess because it can survive harsh environment conditions.
Yes.
I guess the formation of plastic around it would be pretty harsh. So very cool.
Well, There you go. And you're going to get that little nugget here coming up. So unlike fungal spores, bacterial spores have a protective protein wrapping, allowing them to survive in a vegetative state without nutrients. That's the dormant state. This protein shield also enables the bacteria to withstand the high temperature environment during the plastic manufacturing process, which is why they can be embedded inside bulk plastic. You hit it right on the head there, Ben, a moment ago. And this process involves feeding Bacillus subtilis spores and thermoplastic polyurethane pellets into a plastic extruder, which combines and melts them at 135 degrees Celsius into thin plastic strips. And that's 135 Celsius is 275 degrees Fahrenheit. These little bacterium, they can survive this in a dormant state, but they don't get destroyed. That blows my mind. Another notable feature is that the presence of the bacterial spores actually enhances the durability and stretchability of the plastic resulting from this combination. This mirrors the way rebar reinforces concrete, which could make the material attractive for a broader range of applications. So this is like a win-win-win-win-win story. And the research team says they're continuing, of course, to refine this technology. Currently, their goals are to scale up production and explore the degradation of other types of commercial plastics. And by the way, friends, if you want to geek out all the way, you can come out to the show notes, get a link to a study they published in the journal Nature Communications, and we have a link to that as well. But how encouraging is this? I just love it. In the world of dealing with plastics, in the world of generating green energy, there's so much research, so many things going on all at one time. Ben, I've talked about this so many times before in many other areas. It's not just one thing that's going to magically solve everything. It's a combination, and this is just one more little spoke in the wheel of solutions.
Yeah, and this is clearly not meant for every piece of plastic. There are probably things that are plastic that you want, lasting. They mentioned like memory foam. You probably want your mattress to last you, 5-10 years, whatever it may be.
Yes.
And your shoes, you might want them to last more than a year. But things like water bottles and food bags and things like that, that's the kind of stuff that, hey, throw them out, you hope that they degrade. So it's hopeful. Let's see what they can do with it. And again, just you can see the transition if you're watching the video portion, the transition from full-fledged plastic to pretty quickly it like yellows and then starts to curl and break up into eventually something that is much more susceptible to the elements. So there you go.
Right. Cool stuff.
Very cool. So story number 3, story number 4. And I got to say, scientists, they got a real thing for making us swallow sensors. I don't know what they're planning, but this is not the first time we've talked about swallowing pills that are little computers, but this is a different pill for a different problem, and one I did not know was even a thing. So let's go ahead and talk about story number 4 and what scientists are cooking up now.
Yes, you're right on target. We talk about trends. Where are we going? Trends in science and technology. In most cases, folks, on Friday, Ben and I end with a story that's related to medical technology. That's something that's very near and dear to my heart. And as Ben also correctly pointed out, over the last several years, time and time again, we've had stories about magnetically guided little things that the doctors can send through your body and do analysis and so forth. We've also talked about things you can swallow. I don't know, a couple months back, we did an MIT story about a pill you could swallow that vibrated in your stomach and made you think you were full. So to help with diet control and consumption of food and so forth. So this is a big trend in the medical world.
Yeah, and I just have to say in general, like, this is what I love about doing the show, here at Computer America is like, sometimes we have people come on the show and we ask them, kind of what makes your technology different. And a lot of the times, Ralph, it's that the technology just wasn't there 5 years ago, wasn't there 3 years ago. They're taking advantage of new technology and they have new ideas and they're bringing products to market that can, take advantage of this. And, Ralph, I guess back in the day, it was sedate the patient, take a tube and shove it into them and, while they're sedated and have a look around. Now we're getting to the point you just swallow the pill. And like, that's not an advancement of like an idea. That's an advancement of technology. It's just getting smaller and better and, tougher. That's cool.
Yeah. So now here's the headline of the story we're going to wrap up with today. Swallowable sensors could pinpoint gut movement problems for patients. This comes from a wonderful outlet, friends, called medicalexpress.com. In this case, the story was filed by the Heriot-Watt University in Edinburgh, Scotland. So this comes from our friends in Scotland. And a little comment from me, as we've been saying, we've covered multiple stories in the past over the several years about the idea of devices you can swallow for internal medical diagnostics. This, of course, is a good latest example. So here we go. Scientists have developed an ingestible capsule dotted with sensors that can detect pressure in a patient's guts or gastrointestinal tract and detect points of failure. And the ingestible system will give colorectal medical teams an unprecedented understanding of the movement of a patient's digestive tract or lack thereof. Instead of simply taking images of the inside of the gastrointestinal tract, which is what, a colonoscopy where you go and they knock you out, like you said, Ben, and they send a little video camera probe up your back end, and they look around. This is different. This, instead of just looking around, again, to understand the movement of a patient's digestive tract or lack thereof. So it's augmenting the visual with this information. So again, instead of simply taking images of the inside of the gastrointestinal tract, the system will sense whether your gastrointestinal tract is contracting, how much pressure is exerted, and exactly where it might be inactive, where there's points of failure in that whole process of contract and squeeze as you push the nasty stuff out the end, right? So Professor Mark Demulles, I hope I'm saying his name correctly, specializes in medical device technology at Heriot-Watt University in Scotland and leads this project. Professor Demulles said, quote, "The traditional way to look at intestines or the gut is to have an endoscopy. It's a camera attached to a tube that will hopefully see any visible obstructions or problems. We wanted to find a way to detect when the digestive tract isn't working. That's the difference. When it's not contracting and relaxing as it should when pushing waste along. And when there isn't a visible problem." See, that's the, endoscopy can do just so much. But what if the problem isn't something that's visually apparent, but mechanically apparent? That's what this swallowable sensor can pick up on. The mechanics.
Makes sense.
Not just the visual. I love it. So it's so cool. And the system so far has been tested on a synthetic gastrointestinal tract and some animal testing. And a patent for the technology is pending. The team from Heriot-Watt University in Scotland and the University of Birmingham, with colleagues from the University of Edinburgh, have reported their system success in the journal Device. So we have a link to that scholarly paper if you want to dig down deep into this. And get a load of this, Ben. The research team has spent 5 years developing this new system. It's a capsule you can swallow, as we mentioned before. It's 3 centimeters long by 1 centimeter in diameter, dotted with up to 5 very thin sensors, all the thickness of 1 to 2 human hairs. And Professor Demulles says, quote, "The pressure sensors will measure movement and activity right along the 8 or 9 meters of gastrointestinal tract." Every once in a while, I forget how bizarrely weird that gastrointestinal tract is when you think it's 8 to 9 meters.
We're pretty tightly packed in there. So yeah.
Yes. And they will identify regions where there's absolutely no movement of the gut, where the gut is functioning as expected, or if there's something unexpected in terms of movement. So we've had visual, now we have mechanical. I love it.
Yep. So, and like you said, they've already tested on synthetic gastrointestinal tracts. Has been tested in a synthetic gastrointestinal tract. So I guess that means like a synthetic human one, and animals, which I guess means they just went up to a sheep and they were just like, "Here, shove this pill in the sheep," and then the sheep ate it and it worked its way through. But still, and Ralph, like the way that the pictures kind of, pass it off and the way that they kind of talk about it, it's hard to imagine that, if you can pass a pill or you can digest a pill or, swallow a pill, you can probably pass this. So I have high hopes that it should, fly right through the medical boards and, hopefully start helping people soon. So.
Yeah,
very cool.
I agree. Yeah, it's a very, very nice breakthrough. Having had multiple colonoscopies, I can tell you I'd much rather just swallow this guy. But anyway, they'd still probably say we need the visual as well, Ralph. It's visual and mechanical. So sorry, you're not off the hook yet, buddy.
Yeah, you're going to swallow the pill and then be like, Ralph, we found something even deeper. So we got to go in again. And so, no. But ladies and gentlemen, if you want to find out more, of course, you can check out the show notes, computeramerica.com. And while you're doing that, you may notice there's a lot more. This is only about half the show notes. Ralph really outdid himself today. And you can see the honorable mentions, which, as we always say, they're not worse. They're not less. They're not, unimportant. It's just, hey, we try to keep this condensed because we know that, we only have so much of your day. So, Ralph, let's give the nice folks the headlines of the honorable mentions.
Yes, in the show notes, we have the links and everything. First headline, new blood test rapidly identifies life-threatening strokes, enabling timely treatment. When you have a stroke victim, it's incredibly important to first confirm it's a stroke, and so you can get to treatment. But the problem is, to date, the methodologies for identifying this have been cumbersome and time-consuming. This is a new blood test that rapidly identifies life-threatening strokes. So a great story if you're into medical advancements. I highly recommend it. The next one in the honorable mentions category this week, quantum mechanics, definitions, axioms, and key concepts of quantum physics. This is not a news story, but an educational article. I loved this article from livescience.com. Please, if you're interested in quantum mechanics and if you want your brain to be twisted in every possible direction and just put you into a weird place like the TV show Dark Matter that I think is on Apple TV.
But Ralph, the people are asking, when would you ever use something like that? And then I saw the next story. So I can see why you did it.
Yes. Yeah, so, and the next story is related to quantum-inspired laser computing is more effective than both supercomputing and quantum computing, a new startup claims. Okay, that comes from livescience.com, another mind bender. Another story here, Northrop Grumman debuts undetectable military drone submarine. Wow, from mobilityengineeringtech.com. So a really, really interesting story there.
Yeah, looks like a giant manta ray. Very, very cool. But
yes.
ladies and gentlemen, that's about all the time that we have for today. And Ralph, I want to thank you so much for doing this, and everyone out there, I want to thank you for listening. That's all that we ask, and we really appreciate all that you do. Ladies and gentlemen, until next time, computeramerica.com. Again, you'll find everything, including the show notes. And Ralph will catch you here next week. Until then, everyone, have a great day. Thank you so much, and see you next time. Bye, everyone.